And just to bake it down for the uninitiated, what we have here is a two-smoke internal combustion carbonated engine. Gentlemen, welcome back to the shop. Yonder lies a weed whacker of unknown provenance. I checked into this brand. It's the same thing as the McCullough. It's a Walmart brand, 99 Canadian pesos. I couldn't imagine what you pay for this in the United States of freedom. You probably pick these things up after President's Day on a coupon, 3 for a nickel. Nothing says patriotic duty like a fire sale on Chinese gewgaws, am I right? Now, when you're troubleshooting something, not this time. Second easiest thing first. Just a bit of schmoo on there and hard crusties. What from mixing the gas to oilerific. Because this doesn't have an oil sump and it doesn't have an oil sump, you need to mix the lubricating oil in with the fuel, and that's what the fuel, actually, the fuel mixture with the oil is what lubricates the engine. Now, because there's burning oil all the time, I guess it ain't too good for Mother Earth, Gaia, at least that's what they tell me. However, everybody knows that the closer to straight explosions you're running, the better. This is a two-smoke. Of course, a rocket ship space engine, the best engine of all, is a single stroke. Straight explosions. What we here having is the 5.5mm boroscope tip. 10 bucks. I did a video about this just recently. Turned up the LCDs as high as she'll suffer. Yeah, that's pretty ugly. You can see the top of the cylinder there. All gummed up and scoured. There's your trouble. Oh, even if we took this apart, she wouldn't be worth fixing for 99 bucks. Completely fucked. Now that was interesting, but here's the real clue that there's going to be a problem. Still gas in the tank. So, this is probably corn gas, right? It's got 15% ethanol in it, E85. Now, anybody that's ever distilled alcohol knows that you cannot get all the alcohol out unless you use some chemicals. And even then, if it's just sitting around, it absorbs moisture out of the air. It is hygroscopic. And also couple that with the fact that the ethanol turns to vinegar, acetic acid, acid, some sort of acid. Yeah, it's really, really bad for your power equipment. Don't use it. You never put something away with fuel in it. You run it right dry of fuel and then you put it away. Well, now I got a part. I might as well give you the full Monty. You're in luck if you don't know how two-smoke works, two-stroke internal combustion engine works. I'm going to not only tell you, but also show you now. This was assembled in the USA, which is surprising to me. I would have thought this came straight from the Big Rock Candy Mountain, Guangzhou, but not. 2009. This is PA6, which is nylon, of course, glass fiber reinforced 33%. And that is right against the exhaust, so you can tell that's good thermal characteristics under heat, but look at that. Oh, just oozing the cancer. And when you think about this, when you take a step back, this whole thing, nothing on it was grown. It was all mined. All the plastic, all the glass, all the metal, mined. And it all came about because of fossil fuel. You could not make this without fuel. And if you look at things in your everyday life, most of it you would not be able to make without fossil fuel. Even you take a carrot out of your fridge, it's in a plastic bag, that's oil. The carrot, fertilizer for the carrot, that's oil. Right here we have the air intake manifold and the air filter just to keep the big ball bearings out from getting in the engine. Dust is very bad for an engine, so we try and keep it on the outside of the engine. Now the carburetor, all it does is it mixes air and fuel. That's it. And it has a choke, a throttle butterfly here on a shaft that we can turn. And that just changes the ratio of fuel to air. So when we choke it right out, we get more fuel. And when we open it up, when it's nice and warm, we want to choke it when it's cold in order to start it. And then once it's warm, we open this up so it's closer to a stoichiometric ratio. That is the correct amount of air to fuel so that it doesn't run rich, it doesn't run lean, it runs just right. We get the most power out of it that way. However, it's easier to start when it's running rich. That is more fuel than air. So there's a lot of unburnt fuel that comes out of this when it's cold and the choke is on. Now it's easier to wrap your head around if you think of all engines, even turbine engines, as an air pump. And occasionally we have an explosion in there to get power out of, or a continuous explosion in the way of a turbine. But this is an air pump. Think of it that way. And we use that moving air to do a lot of things within the engine. We use it to mix the gas. We also use it to lubricate all the bearings in the two-stroke. And at a certain speed, you've heard maybe of power band in a two-stroke engine. That is when the two-stroke engine is supercharging itself. So again, here's the choke, yeah, and here's the primer ball. This sucks in fuel in order to prime the system. And then we also have a throttle butterfly here. So there's two butterflies, but this one is on a spring. Then what happens is we have two jets here. When air is flowing, okay, and it goes through a restriction, it has to speed up to get through that restriction because it's a smaller hole. If you go from a hole this big to a hole this big, in order to get the same amount of air through there, it needs to speed up. When air speeds up, it creates a vacuum. It drops its pressure. It creates a vacuum. We use that vacuum in the Venturi to do all kinds of wonderful things. One, we use it to suck fuel out of the reservoir and into the bowl. Now this is the carburetor bowl, and it's got a diaphragm in here, and you can see here it's got an equalization port so that that doesn't airlock, and we're able to get this diaphragm to move. So this is all under vacuum, and it's sucking in fuel, and then as the jets suck in fuel and blast them into the Venturi, well, the Venturi sucks the fuel in itself past the jets, the high and low jets. I'll get into that. This starts to run out of fuel. If this starts to run out of fuel, this diaphragm has to move forward. It has to compress. When it compresses, it unseats. You see that? It unseats a little needle valve, and more gas goes in the reservoir here so that it can continually get sucked into the engine and burn. Now I mentioned low and high jets. On this one, they're not adjustable. They're potted off. So you would have to drill that plastic out in order to adjust them. And essentially all they are little needles that are threaded. The further you thread it in, the less fuel you get. The further you thread it out, the more fuel you get. And the low is for low idle. That determines how much fuel it gets when this thing is completely closed. And the high determines how much fuel it gets when it's completely open. And in between there, preferentially it takes from the low jet, and then when it needs it, it takes from the high jet, essentially. And here we can see the adjustment screw for the low idle. All this does, it just controls how wide that crack is, that little crescent moon at the top. There, that's open, that's what's giving you air. And when this thing is in idle, it's trying to suck through there, and it's getting very little air. But then when you crack the throttle, it's allowed to get more air, which increases the amount of fuel available for combustion. More fuel, hotter fire, more power. So the wider this is open, the more fuel it can get and the more power you get. It also speeds the engine up necessarily. So here's the choke, and we'll open that up, and then we can see the high jet right in here, and then the low jet is in the small ID of the small inside diameter of the Venturi tube itself. It's way in there. So what's going on? I drew you a diagram. If my white balance works, okay, air in, and there's a little hole in the choke here, so you always get air through. But this will close up. It'll never close up 100%. There should always be a crescent moon on the actual throttle plate, the throttle butterfly, because remember, this is a two-stroke and lubrication is provided by the oil in the fuel. If you cut off the air, you have zero lubrication and you seize the engine up. So we got to make sure when we adjust these at the low idle, they never close up all the way, because if they seal up, no lubrication, bingo bango, you seize your engine. So here's what's happening. Air goes in. It comes in this big tube here, and in order for us to get the same amount of flow through this small area, it needs to move quicker. It needs to shoot out like a hose, you know, like the nozzle on a hose. Now, when a fluid moves quicker, this is just physics, the pressure in it has to drop. It just has to. It's Bernoulli's principle, has to. I know it sounds counterintuitive that when you're speeding something up, it lowers the pressure, but it does. That low pressure then sucks fuel from the bowl down here in through the low jet, and then when this actually opens up, it'll suck through the high jet. And these jets are just needle valves that you can adjust. Well, they adjust at the factory, and then they seal them up tight. That's pretty much all it is. Fuel goes in here, gets sucked in here, aerated, mixed, and then into the engine. Well, now that we've got all the fuel in there, we need to burn it. We need to ignite it. We need a spark. How do we get the spark? This is the flywheel. This is a counterweight that helps the reciprocal motion of the piston get turned into crankshaft rotary motion. It's essentially a store of energy. Once you get this spinning, it stores energy and keeps that crankshaft moving around, even though the piston is got to change direction. If you didn't have this, the thing wouldn't run for shit, because at the bottom of its stroke it would want to stay there. It wouldn't want to come back up. And we can see here we have a feature, these dogs, these are a clutch, one-way clutch, so that when you pull start it, it engages the dogs and actually gets the thing to turn, but then once it's turning, it doesn't drive the other way, so it doesn't drive the pull start into a low Earth orbit with you attached to it. That'd be bad. And in here we see a little tiny 3/16 square drive, and that is what's driving your trimmer head or your implement or whatever, but in this case it's a trimmer head. And now here's what's really, oh, I can't turn it because it's seized. This is the magneto, and magnet, it's not an X-Men, well, it is an X-Men character, but it came from the magneto in an engine. And what happens is when you have a conductor that is in a changing magnetic field, it creates a voltage, and if the wires are connected, it will push some current. So what we do is this whips past, and this is essentially a transformer with high silicon, high permeability steel laminations that are electrically separated from each other. And what that does is it takes the magnetic flux, there are the magnetos. That takes the magnetic flux and puts it into some copper conductors that are wound in here. Very, very, very fine conductor, lots and lots of them. So what happens is this creates a huge inductive voltage spike when this thing is turning and the magnets swipe past it. Huge inductive voltage spike. We'll have a north pole and a south pole, so it'll go up, up. It'll be an AC signal. And where's that go? Goes to the spark plug. So we have a spark plug with a gap here. Now electricity, dancing pixies don't want to jump that gap, but if we motivate them properly with high voltage, they jump the gap. And it just so happens that this is pinned to the crankshaft in the correct location, so that when we're coming up to top dead center, it sparks, starts to burn, and then whammo! So in short, two magnets, north-south pole, wipes past a transformer that's got a whole bunch of windings on it, creates a voltage in that winding in the primary, and on the secondary side of that transformer there's a whole whack load, a crap load of windings, and it ups the voltage incredibly, so much so that it makes a nice blue pixie dance spark right across here. As you can see, in order to get it to stop, all we need to do is put a switch in there, and if we break that, then no pixies can get across the gap. We don't get any fire, we don't get any power, the engine stalls. That's how we stop the engine. Now I've been burned on this before, my buddy's sailboat, two-stroke of course, and it would work fine on the bench, and then you get it in the boat and it's cough and spitter and die and start right up, no problem, but just no power. Turned out it was this pickup that was starting to delaminate, and it was crapping out. So this isn't a high integrity application. You know, if your weed whacker doesn't work, no big deal. But if your boat, if you're going across the Georgia Strait, or you're going through the Juan de Fuca Strait, or whatever, there's some green water there. You do not want to you don't want to mess with Mother Nature when you're on the water. One thing you do not fuck with is the ocean. So if you ever see one of these on a two-stroke outboard that's slightly wonky, like it looks suspect, and if they're the least bit suspect, yard them. It's getting all delaminated. It might have been like that from the factory, but I would not stake my life on that by any means. Well, we got her chooching back and forth like a choo-choo train, and you can see here's the intake and here's the exhaust. Now the exhaust, yeah, mixed way too much lubricating oil in with the fuel. Smell, you can see. So air fuel comes in this side. Now remember, this is a two-stroke. Comes in this side. And ow, fucker. Bit me. Oh yeah, that's fucked. Wow. You know this is proudly American made. On account of it using inch standard hex heads. When was the last time you saw standard fastener on a hex head? You can't even get a cat with a standard fastener anymore. The times, they are changing. Some say for the better. Ta-da! Okay, we're gonna pull that little baby piston out if we can. Oh, she's tight. Oh man, even sprung a leak. Son of a diddly. Now having a look at that, you see what's different with a four-stroke? Four-stroke doesn't have these slots. And these slots are what are actually getting the gas in and the gas out, not these intakes and exhausts. There's no valves. What it is, it's the piston itself that is the valve. And there we go. There's the pistone. As you can see, it's fucked. Scored right out. Now, no valves in a two-stroke engine. It's just the piston itself is the valve. And you can see, totally different than a four-stroke engine where the valves are in the head. This, no head. It comes up from the crankcase. So what's happening is that the intake and exhaust don't go directly from the ports into the cylinder the way you would think. What's actually happening is on the way up, the piston is sucking air-fuel mixture into the crankcase, and then on the way down, it's actually pushing it into the combustion chamber through these. So up is the suck and down is the blow. Completely different. Whereas a four-stroke engine is suck, blow, bang, spit, this is just suck and blow, or bang and spit. Now the interesting thing about this is the piston acts as its own supercharger. When it hits the right rip'em rate, everything's dialed in, it just fucking takes right off. That's called the power band. It's because the piston is actually supercharging itself. We're blowing things up on this side, and then it's forcing more air-gas mixture into the combustion chamber as it's exhausting out, it's scavenging out all the waste byproducts. And because it's two-stroke, you never get rid of all the exhaust. It's called scavenging. So there's always going to be some exhaust in there, but the stoichiometric ratio has to be set up in the carburetor so that you take into account that there's some inert gas in there or some additional fuel in there, even when it's, you know, that's sort of where you can get more power out of a two-stroke. That's also where it's dirtier. You're getting more oxides of nitrogen as well as particulate matter and just straight up raw fuel, hydrocarbons coming right out of the exhaust, and we can see that. Yeah, spicy. Now, I have a question for you, because some of you guys know better than I do, and I think you like watching the video just to see me trip up, because I ain't afraid to make mistakes, and I do make mistakes. I like it when you call me on it because I always learn something. So here is a question for you. You know, in a Skidoo, it'll run like a hot damn, like a raped ape. It'll just fucking give her, and then next thing you know, the engine calves, blows up. And the reason it calves is because it's got an air leak somewhere on the crank. The crank seal or something is leaking. So it's running really lean. Why do you get more horsepower out of it? Why does it take right off? It doesn't make sense to me. You would think it would run shittier if it was getting more air than it needed. Is it the fact that because there's more air it burns hotter, or how? I don't understand why an air leak in the crank seal would cause it, one, to run leaner, and two, have more power, or at least seem like it has more power by running faster. Somebody could explain that to me. I'd really appreciate it, because I've been asking around guys that know. You know, I watch Donnie79, I think his name is. I'll put his link in the doobly-doo. He's a small engine mechanic. This is what he does. He does YouTube videos on the side just for shits and giggles. And I watch that. And I asked him, and I think he thought I was trolling him, but I really want to know why. Okay, I hope this demystified two smoke engines. Oh, and you can see here also on the magneto, it's got a fan, and it's a directional fan. So you know this engine is only supposed to turn one direction because the vanes of the fan, the cooling fan, are in one direction. So air-cooled, little air-cooled engine, two-stroke. I hope this demystified engines a little bit for you. I enjoy taking shit apart, and I hope you do too. Thanks for watching. Keep your dick in a vice. 6061, you know, aerospace grade aluminum billet. It doesn't cast for shit. The surface tension is too high. So they add some silicon and some 11 herbs and spices for better nucleation and lower, that is, a smaller grain structure when it solidifies, and also lower surface tension when you're pouring it. So this is a lot better to have around than big chunks of machined aluminum billet for casting. So I'm going to keep this around, but I need to know what it is, and there's no marks on there. So I'm just going to take some scrapings here, and then we'll burn the scrapings, see what happens. If they're magnesium, they're going to burn hot. And if they're aluminum, nothing's really going to happen. Yeah, whoopsie. On second thought, I'm not going to burn these until all the gasoline from this stuff flashes off. Huh? Mama didn't raise no fool. And here's the crank counterweight. Well, here's the crank and the counterweight of the crank. Powdered metal gear, or it's powdered metal. So they sinter it in they press it together in a mold, and then they heat it in an oven to just, well, a specific temperature that it doesn't actually melt, but the grains of the metal fuse together. And that's a very cheap manufacturing process, but that's the way it goes. And the pin even is sintered metallic powdered metal, and that's what's left over on the piston. Mineral salts, well, yeah, mineral ash and oil residue. Nasty, pure cancer right there. Not good at all. Of course, the piston ring in aluminum is would be a nice cast iron. This would be a ductile iron piston ring here, and that's all that seals it up. No, that's not true. That's not all that seals it up. Oil is what seals it up, because oil is not just the oil in the fuel. Oil is not just for lubricating. It seals small clearances in the engine. It also provides cooling. It transfers, it's a heat transfer fluid. Cleaning, it's a detergent action. Antioxidation, so that the metals don't rust or oxidize. And also something else, anti-aeration, so it doesn't bubble up, so it doesn't get foamy. What else? There's a whole bunch of functions. You know, you see commercials on the TV about all this oil is so great at lubricating. Well, that's only one function that oil provides.